Hello children, now the continuation of motion in a plane, in this projectile motion. We'll see briefly what is projectile motion. See, an object that is in flight, after it being thrown or projected, which we can call it as a projectile, or we can say the projectile is the name which is given to any body which once thrown into the space with some initial velocity, which moves thereafter under the influence of gravity alone without being any propelled by any engine or maybe the fuels. The path which is followed by a projectile, which we can call it as a trajectory. That example we can say the javelin that thrown by an athlete, and we can say an object which is dropped from the height. This and all we can say some of the examples, right? And we have to be understand that the resultant of two separate simultaneously occurring components, that is along x-axis and along y-axis, we must know, right? The component along the horizontal direction, that is without acceleration, that we can say, right? So the motion along horizontal direction with uniform velocity, and the component along vertical direction, the constant acceleration under the influence of the gravity. That means it is equal to the gravity, we can say, right? So in our study, the air resistance is negligible, we can take, and the acceleration due to gravity is constant over the entire path of the projectile. So we'll see in detail the equation of a projectile motion. For example, suppose a body which is projected horizontally with the velocity of v0 from the point O at the certain height, right? So above the ground level. So suppose the body, that means what is the meaning? The body is under the influence of the two simultaneous independent motion, right? So there is the one, what we say, the uniform horizontal velocity and the vertically downward acceleration motion with the constant acceleration of g, right? So we can say that now the acceleration which we said, that is downward direction. So acceleration a vector which is equal to minus gj cap, right? So now the other components of ax which is equal to 0 and ay which is equal to minus g, it will come. So what is the initial velocity v0 then? The initial velocity v0, which is then v0 x, which is equal to v0 cos theta naught, right? We have taken, and v0 y, for the y component we have taken v0 sin theta naught, right? So the initial position which taken from the origin, so that we have taken x and y component which are 0, then the equation becomes x which is equal to x naught plus v naught xt plus half at square. That equation now must be x which is equal to v naught xt. So v naught xt we have applied here, so that v naught cos theta naught into t. Got it? So for that y component, in the same way we can explain with the sine the component, right? So y which is equal to v naught sine theta naught t minus half gt square. Got it? So the components of velocity at time t, here time t, what will happen? Vx which is equal to v naught x plus at, that becomes, it will be vx which is equal to v naught x, that is equal to v naught cos theta naught. Got it? And for y component, the same way we have written that it is downward direction of g, so that minus gt we have to add it. Now with the help of this graphical representation or trajectory of a projectile which is fired at an angle theta with the horizontal component. What is the horizontal component of velocity? How it will be? It is the velocity remains constant throughout the motion, but the vertical component which gets reduces to 0 at its peak of the path and again increases in the path of opposite direction. Got it? So we are going to explain that with the under the combination of the effect of about 2 components, the body, how it follows the parabolic path. Is it right? It is a parabolic path, right? So we'll see that the equation of trajectory with the help of this diagrammatical expression. So the magnitude of velocity of the projectile at an instant t, which we can say that is Vt, which is equal to root of V naught square cos square theta naught plus V naught sin theta naught minus gt square. We have taken both, right? So you will get it. The direction of velocity of the projectile is, the magnitude is that value, the direction which is, so that you will get tan beta. See the tan beta value that you can get it on V naught for the at t, V which is equal to t, at time t instant, we'll get V naught sin theta naught minus gt by V naught cos theta naught. Got it? So detail of equation of path of projectile, which means that is the trajectory motion. So the trajectory of the projectile we can see now. So the shape of the path we have seen that is a parabolic, right? So that mathematical equation we can see now, that is x which is equal to V naught xt. Is it right? So V naught cos theta naught t. So t, which is nothing but we can get it, that is the t which is, we can say the horizontal, that is which is equal to x by V naught cos theta naught. How we can get means through that horizontal velocity and the horizontal velocity into time, which is equal to, we can call it as x by V naught. So y which is equal to V naught sin theta naught t minus half gt squared. It will be now y which is equal to, both you have take both, y which is equal to what, that V naught sin theta naught into x, that component you have taken, minus half g into t, the t value, here t square will come, no, so x by V naught cos theta naught square. Okay, so by simplifying this equation we will get y which is equal to tan theta naught x minus g by 2 V naught cos naught square, cos theta naught square into x2. The convenient way you can take theta only, no issue. So y which is equal to x tan theta minus g by 2 initial component v, so that V naught square will come, so that V naught into cos square theta, so that we have taken the square out, so that only V naught cos theta square. Got it? So we'll get, we can write this equation as y which is equal to ax minus bx square. So a, in that a we have taken that a and b, that constants, and instead of that the value what, theta, that tan theta, and b value is g by 2 into V naught cos theta square. For that purpose we have taken. So above equation, from that you can get it, the equation of parabola, and also we can get the path of the projectile is also parabolic. We can prove through this. So what is the time to reach the maximum height? So we have taken that, we can say that time of flight of a projectile also. Let Tm, that we have taken as a time taken by the projectile to reach the maximum height. So at the highest point, the vertical component of the velocity will be 0, right? So that v which is equal to, we know that the formula is u plus at, we can apply that through that the u plus at, which means u we have taken here v naught, the value from that we have taken this. So v naught sin theta minus gt, and also it will becomes, because of v which is 0, so that 0 which is equal to v naught sin theta naught minus gt. So what it will be t? So t which is equal to u sin theta by g, so that v naught sin theta by g we will get, right? So this is the time of maximum height. So from this we can say the time of flight. So the time of flight, it is the time taken by the projectile from the instant it is projected till it reaches a point in the horizontal point of the projection. So from this we can say that the net vertical displacement which is covered during the time of flight, which is what, 0, right? So here we can apply the equation, that is S which is equal to ut plus half at square. So that we have applied that t value which is equal to time of flight and y which is equal to 0. So we applied, therefore that we got y which is equal to v naught sine theta t minus half gt square. Then it will become what we said, there is no, net vertical displacement which is 0. So that 0 which is equal to the equation will come instead of that y which is 0. So that only we get the time of flight which is equal to 2 into v naught sine theta by g. Got it? So obviously we know that time of flight which is equal to 2 times of the t, right, the maximum time. Now the maximum height of a projectile, from this we can get the maximum height of the projectile. So we have taken here the hm be the maximum height of the projectile after some time, after the instant of some time. So what we are telling, the maximum vertical distance that is attained by the projectile above the horizontal plane, that is the vertical component of the velocity which is equal to 0. So that we have taken that equation, the same equation, then we are applying that t value, right? So that here you will get hm, the height hm which is equal to v naught sine theta into v naught sine, sine theta by g minus half gt square. So t value square we have applied. Got it? So hm which is equal to v naught square sine square theta by 2g. So from this we got the maximum height, right? So here we can take the maximum height of the projectile vy which is equal to 0. Then we will get this equation vy square which is equal to v naught square sine square theta minus 2gy. Got it? So this v which is 0 means, so 0 square which is equal to the value which came. Then you will get the maximum height which is equal to v naught sine square theta by 2g. And also we can apply in this way, this formula also, that is only we explained. And the range of the horizontal range of the projectile. So what is the horizontal range of the projectile and how it is same for the complement angle of the projection, we can see through this explanation. That is nothing but it is the horizontal distance travelled by the projectile which is during its time of flight, how it is which is moving, right? Here we have taken the horizontal range which is equal to what? The horizontal velocity in the time of flight we can take. So that r which is equal to, we have taken v naught square sine 2 theta by g. So this we can take it from r which is equal to u square sine 2 theta, right? That r which is equal to u. So the horizontal range for that, for example, at different angles we have taken here. For angles 45 theta plus alpha, see that, and if suppose the angle 45 degree minus alpha, right? So as 90 degree plus 2 alpha, 90 degree minus 2 alpha respectively we have taken. These angles you can check it, how we can get it, and the values of sine 90 degree plus 2 alpha and sine 90 degree minus 2 alpha are the same and are equal to cos 2 alpha also. Therefore, the ranges are equal and the elevations which exceeded or fall short of 45 degree and by equal amounts of that. So we can say that in other words too, that the complement angles of elevations, the ranges will be the same. See, that is the theta naught and 90 minus theta, the values of sine 2 theta, or we can say that the sine 180 minus 2 theta, the same, all are same, we can see through this, the diagram, as you can check it. So the 90 minus theta, or it may be the r which is maximum for that, and if suppose it is moving in this way, check. So by this way we got for theta or 90 minus degree, or we can say sine 2 theta and sine 180 minus 2 theta, the values which are same for that, right? So the condition of maximum horizontal range, what we seen, r which is equal to v naught square sine 2 theta by g, right? So clearly r will be the maximum. When suppose the sine 2 theta which is equal to 1, that is equal, that means what? Sine 90 degree. So that 2 theta which is equal to 90 degree, or we can call it as theta which is equal to 45 degree also. So that only we said that the horizontal range of projectile is maximum when it is projected at an angle of 45 degree with the horizontal. Got it? So the maximum horizontal range, that's why we said that, or maximum, if suppose you have taken here, that is v naught square sine 90 degree by g, means what will come? v naught square into 1 by g. So that we will get the r maximum, which will be v naught square by g. Got it, children? So the next one is the range of projectile. So let r be the range of the projectile after the time tf. It is the horizontal distance which is covered by the projectile from its initial position 0, 0 and the position where it passes y which is equal to 0. That y value which is equal to 0. Then c, x which is equal to, we know that v naught xt, so cos theta, and it becomes the range of projectile. So r which is equal to v naught cos theta into time of flight we have taken. So time of flight, that is nothing but what? 2 v naught sin theta by g. So we applied the value and we got, by simplified, r which is equal to v naught square into sin 2 theta by g. Got it? So thank you, children.